Hello everyone, and welcome to Network Labs. Today in this video, we will be doing iBGP configuration on Huawei routers. For our task, we will establish iBGP sessions within our network for both ipv4 and ipv6. In the previous video, all the routers can now reach each other upon configuring OSPF as the IGP protocol. Let us check the IGP routing table and conduct ping test to make sure that all the routers can reach each other before configuring BGP. Let us begin and configure BGP in R1. First enter BGP configuration. Type BGP followed by the AS number. Then, input the router ID using the loopback address. By default, ipv4 address family is created upon entering BGP. Next, configure the peer or neighbor routers manually using their loopback address under BGP globally. Let us start with ipv4. Input the command, peer followed by the neighbor's loopback address. Then the AS number. In iBGP, it is a good practice and recommended to use the loopback address of neighbor routers to peer, and one of the main reasons is it never goes down as long as the router is up. Next, specify the loopback address as the source for iBGP session. iBGP towards R2 is done in R1. Next to configure is neighborship to R3. The configuration is similar facing R2. Here, we will be implementing a full mesh iBGP peering within the AS. In addition, don't forget to put a description in each peer. Next, configure ipv6 BGP peering, which is the same process with ipv4. Let us start with BGP for ipv6 facing R2. The same command using peer followed by R2's ipv6 loopback address, then the AS number. Next is using the loopback address as the source for iBGP session for ipv6. The same with ipv4. Include a description to each peer. R1 facing R2 is done. Continue the configuration for R1 facing R3. Global configuration under BGP is done. Here we can see that ipv4 peers are automatically enabled upon BGP configuration globally. Let us proceed and advertise the loopback address under ipv4 address family. type the network command followed by the network address. That's all for IPv4. Now enter the IPv6 address family and advertise the IPv6 loopback address. As you can see, IPv6 peers are needed to be enabled manually. Enable the neighbors, then proceed with the network advertisement. R1 is done for both IPv4 and IPv6 basic iBGP configuration. Here we have entered BGP globally and configured the basic BGP peering for both IPv4 and IPv6. Then advertise the loopback address under IPv4 and IPv6 address families. Let us copy and edit the BGP configuration in a notepad. To save time, edit the IPv4 and IPv6 peers and description. iBGP peers must be R1 and R3. Also, edit the network advertisement to R2's loopback addresses for IPv4 and IPv6. Copy the updated file and paste to R2. The same process for R3. Change the router ID and the peers, then description. In R3, the neighbors are R1 and R2. Followed by the network advertisement under IPv4 and IPv6 address families. Copy and paste the updated file to R3. We have an error since one of the peers is the router itself. Let us correct and apply it again. R3 is done. Do not forget to save the configuration. That's all for iBGP basic configurations in Huawei routers. Let us go back to R1 and check the BGP neighbors status. First command is to display the BGP neighbors information and different parameters. The result includes the neighbor state, status if up or down, messages sent and received, received prefixes, AS number and peer IP address, and BGP version. For IPv6, type the command. Display ipv6. Peer to achieve similar result with ipv4. BGP neighborship for both ipv4 and ipv6 are fully established in R1. Next command is to verify the BGP routing table. For ipv4, type the command. Display BGP routing table. Here you can see the peer IP, next hop, and different BGP attributes. For ipv6, type the command display BGP ipv6 routing table to verify the routing table. In R1, BGP peers are established, and the routing table is complete for both ipv4 and ipv6. Apply the same commands to R2 and R3. The same results in R2 and R3. One more command is to check the advertised or received prefixes in BGP. Issue the command display BGP routing table followed by peer and IP address. Then receive or advertised routes. For ipv6, issue the command display BGP ipv6. Routing table peer followed by ipv6 address then received or advertised routes. We are done with our task for basic iBGP configuration in Huawei routers. In the future videos, I will include different optimizations and security configurations using Huawei routers. I hope that this is informative to you, and thank you for watching.